Hello, welcome to Code with Richard. And in this episode, I'm going to talk about my solution to LeetCode problem number 23, merge k sorted lists. So here I copied and pasted the problem definition, and I'll read it to you right now. You are given an array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. So this is a pretty good example that they give you. So imagine you have three linked lists, 145, 134, and 2 and 6, and the output will look like this, a single linked list. One thing to notice is that duplicates are allowed in the output, and there's just an explanation of what the actual linked list will look like. And these are singly linked lists. So each node, all it contains is a value. So this node right here will contain the value 1, and it'll point to the next node, which in this case is 4, or the node that contains 4, and the next will point to a node that contains 5, and then the next will be none. And so here's just another example of what the final linked list that should be returned. And there's a couple examples for base cases when we don't have any linked lists or when there's an empty linked list. Here's a couple constraints that are provided to us, and a couple things that I noticed that helped me come up with my solution is that k, which is the number of linked lists in the input, can be quite large, up to 10 to the 4. But if you look at the length of each list right here, it only goes up to 500. So that tells me that you can have a lot of these linked lists, but they're relatively short. And each list themselves are sorted, which is actually something that we'll need. And down below, this is some code that was applied to us, the definition of a list node. As I mentioned before, these are very simple. It contains a value and then a next, and a next can be none. And then the solution takes in a list of these list nodes and will return a single list node. And so let me come back up to here. And I already mentioned some observations that I had. And one is that there's many lists, or there can be many lists. So I'll say can be many lists, and lists are relatively short. And I'll just put that in quotes just because lists can go up to 500. And I consider that relatively short. And my strategy that I thought of is I want to do a merge sort on these. And if you recall from a merge sort, if you're given just a single list, the merge sort basically breaks a list down into two lists, sorts those, breaks those down into two more lists, and recursively does this until it just gets single elements in each of these small lists. And in this case, we're starting into an intermediate merge sort. Like a merge sort has already happened and we're halfway through, and we have a bunch of these lists that we still have left to sort, and they're relatively short. So we have up to 10 to the 4 of these lists that are all sorted, so we don't need to recurse into them, and they're relatively short. So, and they're sorted. So we can actually just recursively just cycle through these and merge these together. And one of the attributes of the merge sort is we could just take the first list, merge it with the second list, take that result, merge it with the next one, and so on and so forth. But that wouldn't actually be a merge sort because merge sorts only actually zip the lists together once without zipping them over and over and over. And what I mean by that is, let's say that we have this list like A, B, and C, and we have a list D, E, and F. If we're given these two lists, the merge sort only takes in these two and merges them together. And they work the best when they are exactly the same length. So you can imagine if we had a bunch more elements in here, and I'm just putting this for illustrative purposes, and these are not actually ordered, that if we wanted to merge these two lists together that are of very different lengths, that it's kind of inefficient. It's more efficient if these lists are the same length. And that's how a merge sort works, is because if you were to merge sort a list, it breaks it exactly in half if it can. And that's what I'm going to do for this big list, because I have a list with up to 10 to the fourth smaller lists, and they're all relatively short. And so let me go down to some pseudocode to illustrate my thoughts. So let's say I have this, oops, not code. I have this merge list function, and I take in lists. So what I'm going to do is I'm going to merge my first two lists together. Okay, but because when I merge this together, the length will double, I don't want to merge this now longer list with the next list. I want to merge the next two lists that are hopefully relatively short. So I'm going to put this new list at the end of the remaining list, and then recursively call my merge list on these. So let me show you an example. So let's say I'm going to call merge list, and my input, I have 4 elements, A, B, C, and D. So I'm going to merge my first two lists together. So I'm going to create a new list called E. And let's just say I have another function that can merge two. And we'll go over this. And merge two will just take two sorted lists and merge those together. So we're going to call this an A and B. And so I merged my first two lists together. Now I'm going to put this new list at the end of the remaining list. So I have my remaining list, C, D, and now E, and I'm going to recursively call merge list on this. So one thing to note is that if A, B, C, and D are all the same length, when we come in, we know that E will be double the length of A and B. So now we have two short lists and a longer list at the end. And so now we can continue. We merge the first two lists. So I'm going to do merge 2 on C and D. And then I'm going to create my new list. We're going to take these, we have E and then F. This is my new list. Oops. And I'm going to recursively call merge list. And let's go ahead and fix this to make it a little bit more readable. Merge list on E and F. And then I'm going to create a G. And my G is I'm going to merge my first two lists. So E and F, we'll merge those together. And then I'm going to recursively call merge list on my G. And I'll have a base case that says, well, I only have one list. I'm just going to return G. So that's like the high level algorithm. I'll take my first two, merge them together, plop it at the end, then take my next two here, merge them together, plop it at the end, and so on and so forth. And again, the reason why I'm going to take two and put it at the end is the way that a merge sort works is it works best when the two smaller lists are exactly the same size. And they may not be exactly the same size if there's an odd number of elements, and that's okay. They could be off by one. And let's now go to my merge 2. Let's say this has list A and list B. And list A and list B in this case are sorted. And what do I want to do in this case, I mean, I can talk about my base cases, which I didn't actually do above, but I have two lists. If one's empty, just return the other one. So if list A is none, then I'm going to return my list B. Likewise, and so list B is none, return my list A. But what do I do in the else case? So in my else case, I actually have a list A and a list B. And first thing I can do is I'll just create a new node. And some kind of new list node. And I need to determine what this head is. So my new node dot head equals my smaller of list A is my head and list B. Head. Okay. And then I need to increment the pointer. So if the first element of list A is the smallest one, this is my new node, and I need to now make list A, basically pop the head of list A off of the list, and list A will point to the next. So I'm going to increment pointer on smaller of list A or list B, whichever one that is, and then recursively call merge to on new list A or list B. And I'm going to set my tail, so my new node tail, or new node.text. So my new node.next equals the result of this, the result of this recursive call. So let's cut this and put this up there. And I'm going to return my new node. Okay, so as a review, my base cases, I have a if list A is none, then just return B. If B is none, return A. And if they're both none, then it's fine. I'll just return none. Otherwise, I'm going to create my new node here. And a new node has a head and a tail, or head and an X. The head is the smaller of A or B. And it doesn't matter which one that is. Whichever one is smaller, I'm going to increment the pointer on the smaller of list A or B. And then I need to set my new node next to a recursive call, where I'm merging the new list A or list B. And then just return that node. Okay, so now we can get back into the actual implementation. And again, this is the list node that's given to us, has a value in an X, and then merge k-list is our solution. And so I'm going to come up here. I'm going to copy the high-level pseudocode comments that I have. Okay. So one thing that I didn't talk about before is our base cases. So let's talk about our base cases. Okay. So the first thing is, well, maybe we have nothing. So I'm just going to check the length. So if my length of my list equals 0, I'm going to return none. Another base case is, well, maybe I don't have anything to sort. So length of my list equals 1. In which case, if I only have one list, there's nothing to sort. It's already sorted. I'm just going to return it. Return list of 0. Okay, and then my else case is I'm going to merge my first two lists together. So let's put this here. So how do I merge my first two lists together? I'm going to say my merge list, and I'm just going to assume that I have this merge to function. And I can take my first list and my second list. And so we're going to merge the first two lists together. Okay, so now I need to put this new list at the end of the remaining list and recursively call merge list on that. And so I'm just going to do it in one line. So so recursively call merge list. And I'm going to need to put this new list at the end of the remaining list. So let's first pick our remaining list. So I'm going to take all the other lists that are not the first two, and I'm going to add that to my merged list. Remember, merged list is a list, but I need to put it inside a list. So what this does is I put this new list, merge list, merge list, at the end of the remaining list, and I'm going to okay, so just as a overview, I have some of my base cases. Of course, I have nothing here. I'm going to return none. If I only have one list, just return that. Otherwise, I'm going to merge the first two together, and then I will take the result of merging the first two together and put it at the end of my remaining list and recursively call myself. Okay. So now I need to create this merge to function. So I'll take A, which is a list node. I'll take B, which is a list node. And this is going to return a list node as well. Sure, merge to will take in two lists, and these lists are sorted in ascending order, and it will return a new list where they're basically zipped together in ascending order. And come up here, I'm going to copy some of the pseudocode that I have. Okay, so I can almost copy my base cases here. Okay, so if A is none, but I'm actually going to simplify this. I'm going to say if not A, I'm just going to return, in this case, is B. Likewise, if not B, then I'm going to return A. So very simple base cases. I don't even know if A and B exist. And if they're both, oops, let's fix that. If they're both none, that's okay. It'll just return none. And that's all right. All right, so we got our base cases out of the way. Now I need to create a new list node. But the head is going to be the smaller of A or B. But when I create my list node, I need to actually specify which one it is. So I'm actually going to put a conditional here to find the smaller. So what is the smaller of A or B? Smaller. And I'm going to put a simple condition. So if A.val is less than B.val. So these are my two cases. My A is smaller or my B is smaller. Okay, so if A is smaller, I'm just going to say my head equals A in this case. So actually, yeah. So instead of creating a new node, I'm just going to take the existing node and use that. Like there's no necessarily reason to create a new node. So I know that this list node A is a smaller one, so I'm just going to keep that as my head. And I need to find out what my tail is. I have to calculate that, and I'm going to recursively call myself. So recursively call merge2 on new list A and new list B. So merge2, and what I'm going to merge, well, I already have A, so I'm going to say my A.next and my B. So basically what I'm doing is saying that the head that I'm going to return now, or my smaller node is A, and now I want to find out what should the tail of my list be. And I'm going to call merge2 on that. So I basically merge the rest of list A with everything in list B. And in my else case, it's just the opposite, where B will be smaller. So my head can be B, and my tail, oops, going a little bit too fast. So I'm going to call, recursively call A, and I'll probably B.next. Yeah, so these are basically the same, they're just flipped. One's smaller than the other. A smaller, then operate on A. B smaller, operate on B. And after these are calculated, I need to actually specify my head.next. Remember, my head is the old list node. That's A. And right now, head.next or A.next points to the rest of my list, but I need to point it to my new tail. So my head.next equals my tail. And then return my head. Okay, so this is maybe a lot to swallow, but let's see if I can talk through it again, see if it makes a little bit more sense. So merge2 will take in two list nodes or linked lists and return a list node. And the inputs are both sorted in ascending order, and the output will be sorted in ascending order. So my base cases, these are pretty simple. Like if A is none, just return B. If B is none, return A. And it's okay if both A and B are none. We'll just return none because A is none, return B, and that's fine. Then it gets to the meat of this algorithm is I need to find out the smaller of A or B. Because remember, my output has to be sorted in ascending order, so I want to pick the smallest one and put that first. So if A is smaller, and I'll just put a note, say A is smaller. So this is the one that I want to pick first. So in pseudocode, I was thinking of creating a new list node, but we actually don't have to create a new list node because we have the list node here. We can just rewire it and point it to the new things. So I'm going to create a pointer head, and it's going to equal A, which is my smaller list node. And then I'm going to recursively merge the rest of the list A and B together. And this tail, this is going to be the tail of my node. This else condition is just the opposite, where B is smaller. And after I create my head and my tail of this new list node, I have to specify that my head.next is my new tail that I calculated. And that's pretty much it. This is my entire solution that I have, and we can jump into testing. Okay, so now I'm going to talk about how I went about testing this. The first thing I did is I created an extra toList method on the list node. And the reason why I wanted to do this is because in tests, constructing and deconstructing these list nodes was a little bit challenging. So what I wanted to do was make the list node able to convert itself into a list itself. So all this does is convert this list node to a list of ints. And I'm just assuming that these values are all integers because that's our test cases are, and that yeah, so when you call the toList, it'll create a list with itself plus all the other nodes behind this. Beyond this, so if you call toList on the head, it'll give you the entire list as an output. I also corrected the spelling on here. I loaded up this unit test file that I have, and basically I created a couple different test cases, some base cases, some very simple cases with a small list, also with some empty lists. This case is the one that LeetCode provided to us. Again, just the input parameter is a list of lists, where each list represents a linked list, and then here is the output. And then I expanded on that test case and just added an extra linked list, and then with the expected output. And all this does is it does a conversion of these Python lists, and it creates these as a linked list. So then we have a list of list nodes, and then we can actually take this list of list nodes and put it into a solution to merge them, and then we just do a comparison. Again, this case is here because we can have an empty list node. And then I created another method to create my list nodes from a list of integers. And this is to show you that this works. Is I can just call my tests and everything pass. So now I know that these tests work, and for this particular solution. So that's pretty much it. I'm sure you have questions. If you do, please leave them in the comments on this video. I'm happy to answer them, and hope you join me next time. Thanks.